Today on How It's Made, Boomerangs. Barbecues. Pinball machines. And strobe lights. Boomerang is a throwback to primitive times. Back then, people threw sticks to hunt, and that's likely how they discovered that certain bent sticks would circle back. Boomerangs have come a long way since then, and are now finely crafted works of art. Boomerangs come in many shapes, but fundamentally, they are all single-wing aircraft. Construction begins with a solid piece of wood. This tree's growth rings have been highlighted to demonstrate how compressed the outer rings become. Because the wood from this section is denser than the inner rings, it's easier to work with. A woodworker takes 16 strips of that dense wood and places them in a steam box for 20 minutes. The steam makes the strips much more flexible. In fact, they're so elastic, they can be bent by hand. Watch how he arcs all 16 layers at once with little effort. The basic form of a boomerang has taken shape. To improve the contour, the strips are clamped into a boomerang-shaped mold. They'll stay in this mold for a day or two, long enough to dry and harden into the bent form. Now it's time to laminate the wood. Glue is spread onto each bent strip. Then, the strips are clamped together again back into the mold. This time, the mold has been coated with wax to prevent the glue from sticking to it. The strips are left to set overnight. The next day, the laminated piece of wood is removed. It's solid but far too chunky to take flight. A woodworker slices it into pieces 8 to 12 millimeters thick. One piece of laminated wood yields about 6 thinner pieces, each of which will become a boomerang in its own right. But it needs more form, and those rough edges have to go. So a more refined design is traced onto the wood and cut out. But there's an easier way to make a boomerang, with sturdy aircraft plywood. With plywood, there's no need to laminate and then physically bend the wood. A woodworker simply cuts out the pattern, then sculpts the tops of the wings with a drum sander. He's made the tops of the wings curve upwards, but in opposite directions. It's this contouring that will make the boomerang fly in a circle. On some models, embedded lead weights are added for improved balance. That laminated boomerang gets the same contouring, but files are used instead of a drum sander. Laminated wood responds better to this technique, but it's much more labor-intensive and requires specialized skill. One mistake in the shape and size, and the boomerang's aerodynamics will be thrown off kilter. But our woodworker has the job down to a fine art. To fine-tune the boomerang, he first softens it over a steaming kettle while twisting the wings into an upward flip. This blower dries the wood to ensure it stays flipped. Then the woodworker sets it on a flat surface to check the curve. A sealant is sprayed onto the boomerang, and finally, it gets several coats of lacquer for a high-gloss finish. And now, these boomerangs are ready to fly. Up next, it's time to get grilling. The barbecue's origins are clouded in a bit of a smoky haze, but it's believed that native Caribbeans were the first to cook this way. Of course, back then, they didn't have charcoal grills. They roasted their meat over a smoky pit. Today, people still love a good cookout, but now we have better equipment. Basic charcoal grills begin with big steel discs. Rollers coat each one with soapy lubricant. Then they're fed into a press that shapes each one into a big bowl. Molding steel can be tricky. If it's not lubricated enough, it could tear instead of bend. So workers need to make sure each disc gets a generous application of the soapy solution before it goes into the press. This is a back view of the press. With each powerful thrust, the ram delivers 500 tons of pressure. A similar type of press makes the barbecue's lids. An operator inspects each part for splits and cracks. Then, it's over to a press that trims the rim. The scrap is tossed into a bin for recycling. Next, the barbecue bowl spins around while an automated roller flanges the rim. After that, holes are punched into the bowl for ventilation. Now it's time to bring in the welding guns. The guns fuse metal couplings to the bowls to serve as attachments for the barbecue's legs. Here, handles are loaded into an assembly machine. Below, a turntable swings the barbecue bowls into position, then the handles are welded to each side. At another station, the barbecue lids get a handle of their own. No chef can check the progress of a burger without this essential part. This one will allow the chef to lower the lid to control the cooking temperature and then lift it again when it's time to flip the burgers. The barbecue parts now travel on an overhead rail to the wash station. They're hosed down with soapy water, then rinsed clean. Once they're dry, it's off to the finishing department. Here, the parts are dusted with a glass powder. Then it's into a red-hot furnace set to 1500 degrees. The furnace bakes the glass dust into an enamel finish that protects the barbecue from rust and stains, so they'll last for years. Next, they go under intense lights that expose any defects in what should be a mirror-like finish. An inspector examines each part inside and out. A punch machine now makes dampers from aluminum. It simultaneously cuts the shapes and embosses the company's logo onto them. This handy attachment enables the chef to control the flow of air to the grill. Nylon grips go onto the handles. And the damper is installed over the lid's ventilation holes. It's up to the consumer to complete the final assembly. And in just a few minutes, the burgers could be grilling. Coming up, a high wire at a pinball factory. Coming up, little lights with lots of flash. Strobe lights often conjure up images of 70s discos. But you'll also find strobe lamps, the proper term by the way, on aircraft wings, in police lights, and on towers and tall buildings to warn low-flying aircraft. Strobe lights even play a role in photography and on factory production lines. A strobe lamp emits repeated flashes of high-intensity light. At this factory, production begins with glass blowers. Using a ribbon burner, they heat glass tubes to almost 3,000 degrees. This softens the glass for bending. But if it's too soft, the tubes will collapse, so the glass workers blow air into it through a rubber hose to build counterpressure. The size and shape of the glass tubes varies by model, but its job is always the same: to house a strobe lamp's essential components: electrodes, lead wires, and xenon gas. The electrodes conduct the current, which charges the gas with electricity, making it illuminate. This factory makes several strobe lamp models, some in large quantities for the mass market, others in small quantities custom designed for specific clients. With mass-produced models, automated machines take over after the glass blowing. Custom orders are handmade from start to finish. Workers even make the electrodes manually. They weigh a precise amount of metal powder and pour it into the cavity of a press similar to what pharmaceutical factories use to make pills. This powder is a blend of several different materials, but the company won't divulge the ingredients. The press applies 4 tons of pressure, compressing the powder into a pellet. The factory inspects every pellet to ensure it meets quality standards. The pellets then undergo a hardening process called sintering. They bake for 9 minutes in a hydrogen-fueled oven. Hydrogen is one of the hottest types of fuel, and the 3,000-degree heat fuses the powder particles into a solid mass that won't crumble apart. Next, workers weld a lead wire to each electrode. Then they insert 2 electrodes, one for the positive current, one for the negative, into each glass tube. Then they melt the end of the tube closed. Then they attach a wire called a trigger lead. It prompts a transformer to send a high-voltage electric pulse to the electrodes, illuminating the gas. This automated machine assembles the factory's mass-produced models. Before starting it up, workers load the components: a pair of electrodes, followed by a glass tube on top. Now, the machine takes over. It vacuums out the air in the tube, injects xenon gas, melts the tube closed, then cuts off the excess glass. The tube's interior must be completely free of contaminants for the gas to illuminate. So just before the vacuum fill and seal operation, a hot coil encircles each tube to burn away any impurities. On custom-made models, all of these steps are done manually. With the strobe lamp complete, it's installation time. This model is for the warning lights you see on tow trucks and road construction vehicles. It goes into a glass reflector lined with metallic film. A transformer regulates the voltage. Its 3 wires connect to the positive, negative, and trigger leads protruding from the lamp. A glass lens cover seals and protects the lamp within the reflector, and then this product is good to go. Strobe lamps are also used in stroboscopes, industrial devices that help factories perform quality control inspections on high-speed production lines. Calibrate the light pulses to the right interval, and they appear to stop the action, so that cameras or workers can examine the goods. It's the size, shape, and configuration of a strobe lamp's components, along with voltage and other electrical specs, that determines how long, how often, and how quickly the light flashes. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/howitsmade.